All right, here we go. Multiplying polynomials. Part of multiplying polynomials fits in with the distributive property we were doing yesterday. So if you'll notice, these first two problems could have been on last night's homework. I have something outside. All I'm going to do is I'm going to take it and I'm going to multiply it through. So let's see, what's 3 times 3? That would be 9. What about p squared times p? P squared times p. If we remember back to our exponent rules, that would be p to the first. And what would we do with the exponents? We would add them. So that actually ends up being p to the third. So as you're multiplying here, you're going to be adding exponents. So I have p to the third right there. Then 3p squared times negative 5. Well, 3 times negative 5 would be negative 15. And of course, I got to have the p squared. Is this in standard form? Yes, indeed it is, because I have the bigger exponent first and the smaller exponent after. So I'm done right there. Okay. How about number 2? I'm going to take the 6r, and that's what I'm distributing. 6r times r would be 6r squared. Again, adding those exponents. Both of those have an exponent of 1. And then 6r times positive 7 would be positive 42r. Is it in standard form? Bigger exponent, smaller exponent? Yes, it is. Okay, so that's our distributive property. Okay, I think I actually have a couple more distributive property down here. Let's go ahead and do those. Number 5 and 6. Don't know why I put them in the middle, but there it is. So I'm going to take 4m squared and I'm going to distribute. What am I going to do with those exponents? Add them. All right, so 4 times, what's in front there? Technically a 1, so 4 times 1 is 4. M squared times m, let's add those exponents and we get m to the third. And then 4 times negative 8 would be negative 32. What about m squared and n? Those exponents I can't add. Why not? Because those bases are different. One's an m and one's an n. So I just have to write m squared n. Now, listen very carefully for a minute. When we talk about standard form for expressions that have more than one letter, we want to keep the letters in alphabetical order, so I have the M before the N, and beyond that, what we look at for standard form is we only look at the letter that comes first alphabetically. So I'm only concerned about the M, the highest exponent on an M coming first, and then the next highest exponent on the M. So this is in standard form. Okay? You look at only the first letter alphabetically. It doesn't matter. That could be an n to the 6th, and even though that exponent is technically higher, since n doesn't come first alphabetically, it does not play a role in putting it in standard form. Okay? And we'll kind of see that and practice it a bit. All right, 5 times 5x. Well, that would be 25x. And 5 times 2y, that would be 10y. Now, both of those have the same exponent, so is it in standard form? Well, looking at those two letters, are they in alphabetical order? Yes, the x comes first before the y, so that would be considered standard form. Okay? Now, looking at the problems we have left, number 3 looks very similar to number 8. Main difference being number 8 has 2 letters in it, number 3 only has 1. Number 4 looks very similar to number 7, except that number 4 only has 1 letter and number 7 has 2 letters. So let's start with the single letter ones. 3x plus 6, this is one of those ones that people want to think that they can just distribute that to. You cannot distribute the 2 unless what's inside is multiplication. And is that multiplication? So I have to think about this as 3x plus 6 times 3x plus 6. And the way I'm going to show you to multiply these, there's a couple different ways. You can do what's called double distributive, which means you would take the 3x and you would distribute it through the other side. And then you would take the 6 and you would distribute it. And then you'd combine all your like terms. I'm going to do something called the box method because I think that is very, very helpful for people. I'm going to make a box. Since I have 2 terms, 1, 2 in this first one, I need 2 rows. And since I have 2 terms in my second one, I need 2 columns. I'm going to take my first set of parentheses, and each term is going to get its own row. So I put the 3x here, and I put the 6 there. The second parentheses is going to go along the top. So I have 3x, and I have 6. And what I've made here is like a multiplication table. So I'm just going to multiply as though this was a regular multiplication table. 3x times 3x is going to give me 9x squared. 3x times 6 would give me 18x. 6 times 3x would also give me 18x. And 6 times 6 gives me 36. What I like about the table is I have 4 terms here. My like terms are always going to be on a diagonal from each other. So if I want to write out my answer, it's easy to find my like terms. And standard form is also easy because usually my biggest exponent is up in the corner and it works down. So 9x squared is the first term of my answer. And then how many x's do I have if I have 18x and 18x? That's going to give me 36x. And then finally I have a plus 36. Are we in standard form? Bigger exponent, smaller exponent, nothing. That is standard form. Okay. Let's try that box method again on number 4. Now this one I don't have to worry about writing the parentheses twice. I'm just going to go straight to my box. Again, I need a 2 by 2 box. And don't be afraid to make your box kind of big, because if you make it too small, you end up squishing things in, and it's just harder to read. Sorry about that. That's not your bell. All right, 4v and then 7. And up here I have a 2v. And now I have a minus, which means this is going to be a negative 4. That's how that minus comes into play. And now we multiply. 4v times 2v would be 8v squared. 4v times negative 4 would be negative 16v. 7 times 2v is 14v. And 7 times negative 4 would be negative 28. Again, you see your like terms right there on the diagonal. So I'm going to write 8v squared first. And then what do I have if I have 14 and negative 16? I think that gives me negative 2v and then minus 28. Okay. Pretty easy, right? All right. So if I go down to 7 and 8, the same process applies even though we have 2 letters. So let's see. Let's draw our box. Again, I have a 2 by 2 box. 2 this way, 2 this way. 8x and 5y go right there. And up here 6x and negative 3y. So let's see, what is 8x times 6x? Well, I know it's going to be an x squared, and 8 times 6 is 48. And now this way, 8 times negative 3 is negative 24, and x times y, I want to write in alphabetical order, so I call it xy. Next I have 5y. 5y times 6x. Well, 5 times 6 is 30, and y times x, again, alphabetical order, call it xy. And finally, 5y times negative 3y would be negative 15y squared. So, standard form here gets a little trickier. What letter am I looking at when I'm looking at standard form? Which letter comes first alphabetically? In this case, it's x. So I'm following the x exponents. That's the highest x exponent. So I have 48x squared. Then these two both have x's in them, so they need to come next. They're my like terms. 30 and negative 24 would be positive 6xy. And then lastly, I put the one that doesn't have an x, that's 15y squared. So even though the exponent here is higher than the exponent there, it's all about the fact that that exponent is not on an x. I have to go by the x's for standard form. Okay? All right, let's look at this last one. What's the issue with this last one? Again, I do not have multiplication, so I need to look at that too as writing this as 3x minus 6y times 3x minus 6y. Let's set up our box. Again, a 2 by 2. Tomorrow we'll get into some that aren't 2 by 2. 3x and negative 6y. and then 3x and negative 6y. Why don't you go ahead and take a minute and multiply those out, and then write your answer in standard form. All right, let's finish this off. 3x times 3x would be 9x squared. 3x times negative 6y would be negative 18xy. Keep those letters in alphabetical order. Negative 6y times 3x would be negative 18xy. Keep the letters in alphabetical order. And negative 6y times negative 6y would be positive 36 y squared. I have x's and y's. X comes first alphabetically, so that's what determines standard form. So 9x squared, and then I got to do these guys, negative 18 and negative 18 is negative 36xy, and then last but not least, plus 36y squared, and that's my final answer. Okay? All right. Happy studying.